Hello, my name is Dave Dickey, and I'm taking some time to go through the back to school nights presentation because some folks weren't able to see that. So need about 10 minutes of your time. Thanks for joining me. So welcome, and let me go through a few things regarding engineering design technology. One is the syllabus. So, and I'll also share some things from some of the projects we'll be working through. Okay, so let me start with the syllabus and talk about that regarding engineering design technology. So in our syllabus, first of all, this class is a college class, and it is articulated with Pasadena City College. The name of the class at Pasadena City College is DT8A, Introduction to Digital Design and Fabrication. And what that means is that this class gives college credit as long as students finish with a B or better and a good portfolio. Also, just be aware they have to take one academic class at PCC, whether that be during the year or in the summer, to get the credit on their transcripts at PCC. So that's part of their requirements, is to take one class with that. So please be aware of that. My office hours are going to be Friday mainly. Students can contact me in the afternoon, but also Friday mainly in the morning. I'm available for tutoring and other things. Okay. In the course description, we're preparing the students, obviously, according to the standards of the class at PCC, and this is part of that. And they're learning skills in computer design, and engineering, and fabrication. And so in general, more of like an industrial design class, but based on the first engineering class in the program at PCC and other colleges, okay? And the student learning outcomes, when we're finished, they should be able to be very proficient in CAD and 3D. If they take the second class, which I teach, they can work towards a SolidWorks certification, and an exam for that will be given in the spring of the second year. And they go on to become, many students go on to become TAs, teacher assistants in college, in SolidWorks classes. For example, my daughter does that at University of Washington. She's the TA, she does part of the teaching, she does the labs, does tutoring, and she also gets paid. So that's a great deal. So good experience for her. So that's really what we're preparing them for. Materials and textbooks. The textbooks we have is a digital textbook. It's licensed with the company I get it from, and so I send out the chapters one at a time. Students can print those out and draw on those and take notes. That's why I've done that. As far as equipment and tools, I'll be providing materials for the projects we'll be doing, probably 3 to 4 projects at home. Again, to be able to come and pick up the project packets and go home and be able to kind of create those either by themselves or in teams. And if it's a team, they'll be working collaboratively with other students, obviously not together, but online. Okay. Attendance and tardy assurances are just part of the school policy. I do take off about 25% of the possible credit per day for assignments that are late. And we talked about that with the students. I'm trying to create right now a unique kind of class environment with students so that they feel welcome or at home, but also challenged, have a voice, and are prepared to work within the community. Okay. I rarely have discipline issues. If I do have those, I'll talk to the students first and try to work that out. If not, I'll come to you as a parent or guardian, and we'll kind of go from there. Okay. I do give quizzes and exams. Most of the points will probably be through their project work, which I'll be looking for each week, probably sets of slides, Google Slides they'll turn in regarding their work each week, okay? And this is my grading policy here, all right? And if you have questions, please email me about this, and I'd be happy to respond. Let me share some of the projects we'll be working on in the class, and this isn't in any specific order, but for example, here's one thing is, like, as they get into 3D, they are learn to make presentations for the portfolio and also at a college level. Okay, I'm literally taking the USC standards to try to help them create their portfolios. So in this one here, Nicole Human did in the spring of 2019, And so they were supposed to choose an appliance to create, do research on that, what they would like to do. She chose a rice cooker, obviously. Choose materials and colors, look into the function of the appliance, and then begin doing sketches of their own design. It should be a working sketch. In other words, it has controls and it could be functioning if it were real. And so she began to create this. And this is after learning 3D and in a software called SolidWorks. Okay. And by the way, all the software we use is all either free or free to them as students, okay, to download. And so she begins developing this. My goal for them is to create authorship in their designs and presentations so that the reader can see that they are doing this themselves, and as they describe what they're doing, that provides the authorship of their designs. And they do it this week by week. They have, as they create this, and we walk through, and I'm teaching throughout this time about how to create things and how to use the software as well. So it's a great teaching tool. They can be very creative as long as they stay within my parameters, and that tends to be very enjoyable to most students. And then finally, they are creating something that is finished, but also realistic. So they have these realistic models they've created, and my goal is for them, I tell them, it has to be able to go online for a company. So this is like, can you make it so it sits in a counter with shadowing and backgrounds and looking very realistic, as if the buttons are lit and on and running. And so that's the idea. So conclusions help them to kind of look toward the future as well on this. All right. The next thing is let me stop this and make sure I'm going to the right link next. So this Catapult design, also by Nicole, but because she did a great job, but she had a different partner for this. But this is where, in the beginning of the class, where they're learning to create mechanisms to shoot ping pong balls, okay, into a target. And so again, they've learned how to do isometrics and drawings and sketches. A 2D mock-up shows how this mechanism would function if it was a flat mechanism. How would it function with rubber bands? They use SketchUp, which is another free CAD software, 3D software, to actually design it with dimensions so as to scale. And as they design this in a team, they're moving forward as how this is going to work, how it's going to actually function, and thinking through that. And we talk through the mechanism properties and how it should work and the sizes and all those things. When they're done with that, they go on to actually create it. And again, I provide materials for this. They create the mechanism to their designs. They measure it out, they cut the parts, they put it together, matching their design, and explain that and go through that. So that's the idea. When they're finished, they are, again, this is what they're shooting towards. They compete in each class and among the 3 classes of students. And we've had 45 teams, I think, last year. Around that, and so it's a great time of competition and fun, and students really enjoyed this. So this year I will have them compete, but they may bring their mechanism to school, we'll test it in the parking lot or something like that. We'll see how it goes. All right. Lastly, I want to talk about 3D printing, and in the lab here, if you can see my background, back here on the right over here in your screen, I actually have a room with 10 3D printers. And I'm very well supported by the district, and I need that many to actually be able to print all the projects, because one print can take an hour or more. And so imagine you're doing 100 prints, and so it helps me to work through that. So in this project here, one example is this phone stand design, and where students had to look online and find ideas, but then create their own. Okay. And so his was a modification of one he'd seen, but again, they're doing sketching, and then we talked through 3D printing and the strategies for that to make it work, and sizes and parameters, and how to make things that fit together when they're printed without sticking together as they're printed from the ground up with the 3D printers. And so they learned about that. They learned about the function, how they can make it work. In this picture right here, they're using a cone design. If you notice this, cone designs are printed as one piece, okay? And then it is brought up from there. So I'll show you a picture of that. They have to do renderings to make it look photorealistic and like that. And then here's the actual print that is designed. Notice in the bottom right here, it's printed flat as one piece. And again, it can't, the pieces, like when you have a cone design, it's supposed to literally come together. Let me show this with my hands here, but you have a print that's coming together like this, and it has to be able to rotate within that. So there's some spacing, there's some tolerances that have to be met within the parts. And then as it's printed and expanded, it just comes up in one piece. So it's kind of fun to see, and the students have done really well. And again, they're talking in conclusion about what they've learned and how they've grown from this and learned more skills. So great experience. Lastly, I want to say, and this is like 3 of probably 4 or 5 projects we'll be working on. And again, going through all the different parts of engineering and design and drafting and orthographics and isometrics, all the different parts of that before we get to the projects in many ways. Sometimes I teach that through the project, sometimes it happens beforehand, okay? Lastly, one of the goals is to have them get this certification that I mentioned before, where this is the certificate for that in the 2nd year, where they actually get SOLIDWORKS certified. And so I'm preparing them for that in the 1st year, and the 2nd year we do this and work heavily to do this. Let me just say that we have about a 90 to 95% passing rate, and PCC's rate is around, I think, in the low 80%. Nationally, it's about 78% passing rate for this international adult level exam. So our students do really well. Okay, so I hope they can go on to the 2nd year and achieve this. It's a great milestone for them. All right, that is it for now. And again, let me know if you have questions. Feel free to email me, which is at the top of the syllabus information there. And otherwise, thanks for your interest and your support of your students. Okay, all right, take care. Bye-bye.